Thanks for stopping by to check out another fun-filled, action-packed episode of Vintage Audio Review. In this episode, I'm going to talk about this Fisher EQ-276. So what would possess me to talk about a piece of Fisher equipment? Well, about 3 years ago, a coworker friend of mine, we'll just call him Mason, gave me a bunch of audio equipment that he no longer had a use for. And one of the items was this Fisher equalizer. Now, I've already got 2 equalizers in 2 of my systems, and I didn't really need a third, but I figured that it would be kind of fun to look at and see what its performance was, and whether it could be something that I could use on another system at some point in time. In case you're wondering, an equalizer is just an advanced set of tone controls like your bass and treble controls. You just have a much wider selection. This particular one is a 10-band equalizer with a plus or minus 12 dB range. Now this particular one has a normal power cord. Some of the Fisher systems have a special AC power cord for like the equalizer for the turntable, and they're kind of a special plug that plugs into the integrated amplifier for their power. But this is not one of those, thank heaven. So I was able to find a little bit of information on this equalizer, and it was part of what is known as a Fisher 276 stereo system, which included a linear tracking turntable, a tuner, a CD player, a cassette deck, as well as an integrated amplifier, and of course this equalizer. The equalizer did have a spec of a signal to noise ratio of at least 100 dB, and THD was supposedly less than 0.01%, and this is from 20 Hz to 20 kHz. So it has some nice specs at least. So we're going to look at a close-up of the unit, and we'll have it operating so you can see some of the meter movements, and we'll look at the back as well, and then we'll go into some measurements, actually quite a few measurements on the equalizer, and we'll talk about my opinion at the end. And at the end I'll kind of summarize what I think the measurements tell us. Okay, so here we have the Fisher EQ-276, and the power buttons here. We do have our 10 bands starting at 32 Hz going up to 16 kilohertz. Now the sliders are detented in the center position at 0 dB, so that's kind of a nice, so you can always get them right to 0 should you want. There is an analyzer level here, so if I move that down, it's going to change the overall level that's being displayed. So if you have a real strong signal, you don't need as much gain in that display. It's not automatically done, but that is the level there. And you have a total level display, and that's like a sum of all the bands together. We'll just turn that down a little bit. I do have some music input into it. Now here is our equalizer record control. So the EQ record, when I press it on, we see the little LED comes on. And what that will allow you to do is use the equalizer in a tape monitor circuit, so you could adjust a recording you were making on a cassette deck or reel-to-reel if you so desired. Here is our EQ on and off button, and if you just want to bypass the equalizer, you can press it in. So if you wanted just to use the equalizer as a display only, and you can see that the signals are still being displayed, you could use it for that. So this is the tape monitor source switch. So right now the little green LED is on source, so it's looking at the source that's coming in, and if I put it on to the tape, then it will be looking at the tape monitor circuit. And when we put it on tape, since we're not in the tape monitor loop, the signal all goes away. We also have our display, whether we want the display totally off. Maybe you're trying to go to bed at night and you don't want the display coming on, or you can just display the left channel only, or you can display both channels. If I wanted just the left channel on, I can press it and there's just the left channel. Notice the signal level is kind of low. If I bring the right channel up, then the signal level goes higher. So that kind of lets you have either left or right or none. So that's kind of what the equalizer does, and we'll look around back here in just a second. So here is the rear of the EQ-276. I bet you never would have guessed that. We do have an unswitched outlet, which is kind of nice, and we have our line in and out and our tape in and out connections here. Now, one thing I should point out is based on the data, this can handle at least 2 volts going into it without distorted. I didn't run it higher than that, but with at least 2 volts coming into it. You could run it between the pre-out and main-in connections on an integrated amplifier, or between a preamp and an amplifier. So normally you would run this in the tape monitor circuit. It's probably a good idea, but if you did want to, you could run it between your pre-out main-in jack. So this first plot shows the frequency response of the equalizer with it in the out position. So it's pretty darn good, about 0.2 of a dB, worst case flatness. So I would say that it is not affecting the signal very much at all. So here we have the frequency response with the equalizer switched in and all the tone controls set to 0 dB or the flat position. And we can see that the channel balance is pretty good, maybe 0.1 of a dB, worst case between the left and right channels, and we're still down not more than 0.3 of a dB at the high end of the band as far as flatness goes. So it's still pretty good. So here we have the THD SNR plot at 1 kilohertz with the equalizer switched out of the system, and it's looking really, really good. So here we have the THD SNR plot at 1 kilohertz once again with the equalizer on, but we set the 1 kilohertz slider for 6 dB of gain. The first thing you'll notice is that we're only getting about 2.53 dB on the right channel and 2.92 dB on the left channel for gain. We should be getting 6 according to the scale on the equalizer. That being said, the THD improved from no gain, as did the THD plus noise and the SNR, and that's because the signal at 1 kilohertz went up greater than the noise and distortion went up. So once again, we have the THD SNR plot at 1 kilohertz. In this case, the right channel was set for flat, or 0 dB of gain, and the left channel was set for plus 12 dB of gain. And you can tell that while the SNR got really good, the distortion is right near 1% for the left channel, and the THD plus noise for the left channel does not look very good. Plus you can see the distortion on the left channel waveform. So that is why you would not want to ever boost a signal 12 dB. So here we have the THD SNR plot at 16 kilohertz with just the left channel boosted by 12 dB and the right channel was set flat. You can tell that in this case the gain, or the boost, is 11.4 dB, which is close enough to 12 dB of gain. And you can also see the SNR is looking pretty good, and the THD is crept up to 0.6%. However, the THD plus noise has gone down to a minus 44 dB, so that's not looking too well. So you probably would not want to boost your gain by 12 dB at 16 kilohertz. Here we have a THD SNR plot for a 32 hertz input signal with the equalizer controls all set for 0 dB or flat. And you can tell that there is an increase in distortion to about 0.06%, which is still not bad. It's an increase from where the distortion was at 1 kilohertz. However, the SNR has gotten worse, as has the THD plus noise, which basically is the SNR. So here we have the THD SNR plot with the same 32 hertz input signal applied. In this case, the right channel was left at 0 dB and the left channel was boosted by 12 dB. You can see that our gain for the left channel is 10.63 dB, and then if we noted that we started off about minus 0.5 of a dB or so before, we're really at about 11 dB of gain, which is close enough to 12 dB. However, the SNR has gone to pot. It's almost 39 dB, and the THD has gone to about 0.5%, and the THD plus noise is also about 39 dB. So you probably wouldn't want to do a 12 dB boost at 32 hertz. So to make this plot, I started off at 32 hertz and boosted it by 6 dB. There is no detent for 6 dB, only the 0 dB point. So I was eyeballing it. And then I ran a frequency response from 20 hertz to 20 kilohertz. Then I put the control back to 0 at 32 Hertz, and then I went to 63 Hertz, boosted it by 6 dB, and did a frequency response measurement from 20 to 20 kilohertz. And then I just repeated the process until I measured all 10 bands with a 6 dB boost. Now what you can tell is that we really don't get 6 dB boost. At best case, we get 3.5 dB boost maybe, because the big wide blue line at the bottom is actually at, we'll say, minus half a dB. And you look at some of these here, the 32 Hertz is at 3 dB, and if you added half a dB, we've got 3.5 dB. So at the closest we got to 6 dB was 3.5 dB. So you're not really getting 6 dB a boost, you're getting more like 3.5 dB or even less at some frequency points. So this plot was made by taking all 10 sliders and placing them either in the plus 4 dB position or the minus 4 dB position as best as I could eyeball it, and then running a frequency response. Right off the bat, I would have kind of thought that you would see pretty much plus or minus 4 dB of gain or loss across the band, but we are not seeing that. Surprise, surprise. So if you look at 1 kilohertz, we'll just take that frequency. You can see that there, instead of a 4 dB gain, we're seeing about a plus 8 dB gain for the right channel and a plus 7 dB gain for the left channel. And when we look at the minus 4 dB position, we're looking at more like 7 dB of gain for the right channel and 9 dB gain for the left channel at 1 kilohertz. So we're definitely not seeing a plus or minus 4 dB effect by having all the sliders at either plus 4 dB or minus 4 dB, and that probably has to do with an accumulative effect that you saw on the previous graph. So this graph shows the effect on input signal level versus frequency in THD from 20 Hertz to 20 kilohertz with the equalizer set flat on all channels. Now I'm just showing the left channel, but would expect similar results for the right channel. And the spec was less than 0.01% THD from 20 Hertz to 20 kilohertz. Well, we are not meeting that. However, we're close for the minus 6 and minus 9 dBV input levels from 70 Hertz on up. Even the worst case input signal level of 6 dB or 2 volts, we still are less than 0.2% distortion across the band with all the controls set flat. So that's really not too bad unless you're a real purist. So here we have the THD SNR plot for a 1 kilohertz signal applied with the equalizer set for a minus 6 dB of gain or 6 dB of attenuation at 1 kilohertz. If you compare that with the 1 kilohertz 0 dB plot earlier in this presentation, you will see that the SNR degraded by about 5 dB and the THD degraded as well, although it's still pretty decent here. And of course the THD plus noise degraded here in this attenuation state, which is what you would expect. This last piece of data shows the multi-tone response of the Fisher EQ-276 with all the controls set flat, and it shows about 12 or 13 bits of distortion-free range. I think the data shows that the Fisher EQ is not a bad little device as far as adding extra artifacts to your music. Now it does add some, it is an equalizer and something in the signal path, but I think the amount that it adds is pretty minuscule compared to the gain you may have to offset room acoustics or speaker deficiencies. So my biggest complaint with this equalizer, and it's a personal thing, is that you have only one graphic display for both channels. Now you can have it just display left channel or right channel or both channels at one time, but it's still a single display. Being an engineer, I like to have as many gauges and indicators of how things are doing as I can. So I really like to have a separate display for the right channel and a separate display for the left channel. So one other nitpick I have on the equalizer is that when you're adjusting one of the sliders, what you think you're adjusting for, like say if you're adjusting for plus 6 dB, you might only be putting it at plus 3.5 dB. But that's not overly critical because you should be adjusting a little bit for the sound more than, oh, I just need 6 dB here. I probably wouldn't crank up more than about 8 dB indicated on a slider, because you start getting a lot of distortion once you start getting up in the greater gain settings. That being said, for a free thing, it is nice, and at some point I probably will find a place for it. So the cost of this to me was free, so that's always nice. Now I did have to spend some time cleaning all the switches up front as well as all the sliders using deoxit and this GC cleaner that I started using as well. And I did all the sliders and all the switches before I even started the measurements, which it needed to have done to it. Once that was done, everything seemed to settle in place. But that being said, it's not a bad little unit, and at some point in time I may be able to actually use it in a stereo somewhere. Once again, I thank you for taking the time out of your busy day or night to watch this episode of Vintage Audio Review. And if you haven't subscribed, please do so, and I would welcome to hear any of your comments below. Thank you, and have a great day or night.